All right, so welcome back. This is part 2 of our notes. This is the back side. So when we have word problems. So for the notes, I put pictures on there for you. On our practice, sometimes we're just going to have to draw the pictures ourselves or sketch them. Obviously, not this detailed, but we will have to make sure that each one has a triangle in it because that's our objective, is to get a triangle with sides and use the Pythagorean theorem. So we're still going with a squared plus b squared equals c squared, okay? A is a side, b is a side. Does not matter which one it is. C is our longest side, called the hypotenuse, and it's always across from the 90-degree angle. So if you look at this picture, even before I read, I can tell right now this question mark we're looking for is going to be our C because it's across from the 90-degree angle. But if the picture's not there for you, which some of the practice, it won't be on there, we have to draw the triangle out ourselves. But it says to get from point A to B, this would be across a pond. You must avoid walking through the pond. To avoid the pond, you must walk 34 meters south. That's where they're talking about where you go down. That's how they got the 34 meters. So we walked 34 south, and then you walk 40 east, right? That's how they got the two sides of the triangle. They just drew it for you. So they're showing you how to do it. Okay, and then it says to the nearest meter, how many meters would we save if it was possible to walk through the pond? So we're just going to take side. So we know which, we have two sides. So 34 squared plus 41 squared equals, we're going to see what that missing question mark is. So this is one, actually, this is from example 1 of the very first day of notes. When we're looking for the hypotenuse, it's only 2 steps we need to do. So 34 squared plus 41 squared. So we can put all that in our calculator and we get 2,837 equals c squared. And then our next step is just to take the square root of both sides. Take the square root and then 2837. So it says we're going to round to the nearest meter. So it wants us actually to do a whole number, it looks like. So it would be about, C is about 53 meters. If you put 54, that's okay too, but rounding wise, because it's a 0.26, we would actually round down. Okay? All right, let's look at the next one, even if there wasn't a picture. This one gives you a little picture, but you actually have to draw it yourself because we're talking about triangles. So a baseball diamond is a square with sides of 90 feet. What is the shortest distance to the nearest tenth of a foot between first base and third base? So I would start out with, let's draw our diamond, which we know is just a square on the side, a baseball field, and we know that every side is 90 feet, right? 90, 90. Okay, it wants to know from first to third base. So this would be home plate, right? This would be first, this is second, this is third. For those of you that don't play baseball or softball, hopefully you would know this. If you didn't, this one would be a little bit difficult. But, so we know this right now, and it says, what is the shortest distance from first to third? So basically it's asking us to just cut this in half, right? What's the distance right here? So we're looking for this, the C, and we already know every side is 90. So I could put in 90 and 90. It's a square with all sides are 90. So right away, I know that's going to be my 90-degree angle here, and we're looking for the diagonal. So we would get 90 squared plus 90 squared equals, and then again, we're looking for the longest part there. That's the hypotenuse. So we would just put that all in our calculator. 90 squared plus 90 squared. And then that's 162,000 equals c squared. And then our last step, take the square root of that number. So second square root, 16200, and enter. So it's about 127 feet. So C is about 127 feet because we took the square root of both sides. It cancels out here. So both of those were, you found the hypotenuse, so it made it a little bit easier. Okay, we know that no matter what the story problem is, we're going to be drawing a triangle with a 90 degrees. So those are givens, which makes it a little bit easier for story problems because we're always going to have a triangle at some point, whether it's we cut a square in half, whether it's we cut a rectangle in half, or we just have a square. Let's look at this last example. So it says a suitcase measures 24 inches long and 18 high. So I would redraw the suitcase. And obviously if it's 24 on this side, it's 24 on this side. It's a rectangle. And then if it's 18 high, so over here, it's 18. It's also 18 here. Now we know we're going to have to do a triangle. So I know right away we're going to actually cut this in half without writing more of the problem. And then it's going to ask you, what is the diagonal length? That's our C. Okay, so that's the 90-degree angle, and we're looking for C. So this is another one. We just drew the picture. We knew it was going to be some kind of triangle in the end. So we have 18 squared plus 24 squared equals C squared. So this is another one where it's nice because we can enter it all in our calculator. 18 squared plus 24 squared, and we get 900 equals C squared. And then the last step is we take the square root, it cancels, and C is about the diagonal length, so the square root, so second, and that sign, 900, so it's actually exactly 30 inches. That's the diagonal's length. So that is the second part of the video. I'm also going to go into the homework in this part and do a couple with you. So if you want to pause the video, you're going to get the practice 2 and practice 3, and we're going to look at those together really quickly, do a couple, and then you will be on your own. Okay, so this is practice 2. This goes with the front side of our note page. And like I said, this one's actually kind of nicer. It puts the diagonals or lines in for you. Some of them won't actually even be diagonals. They'll be so simple. And the other ones will actually just draw it in. So let's look at number 1. I'm going to draw in the diagonals. The diagonal's already drawn in. I'm going to drop down the lines and draw in the rest to make the triangle. So this is a really thin triangle. So I'm actually going to there we go. So it looks a little bigger for you. So I'm going to drop that down all the way. That's one of the sides, and I'm going to count. That actually takes me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this side is 10. I'm going to draw that in, and then if you look over here, I go this way, and that's actually this side is 1. It wouldn't matter what way you drew the triangle. So remember I showed you on the notes we could do it this way too. So I actually could go over here on the top and then go down this way. It does not matter. So do it whichever way that you'd like. So then here I have, it's looking for, this is when we're looking for a diagonal, it's actually just side squared plus side squared equals C squared. So these are a little bit easier. So again, we're just going to put all that in our calculator. 10, oops, it's kind of hard to see. Let me zoom out again. So 10 squared plus 1 squared gives us 101. Yes, we probably could have done that in our head, I hope, but we're still going to always use our calculator. And then the square root on both sides, the square root, it cancels out. And then I type in second square root and then 101. So then I get C is about, and we're going to actually just do to the nearest 10. So 10 point, it's actually 0 because it's 0, 4, something, something, something. So just to be more precise. So that's our answer. So when you go to do these, you are doing evens only, which means you are going to do, you are going to do evens only. So what's nice about that is if you look at number 4, let's star that. Do we need to draw a triangle if we already have a straight horizontal line, or can we just count the distance? Yes, we can just count it. Star number 6. Number 6 doesn't have a lot of work either because it's a straight vertical line, which means we don't have to use the formula when it's not a diagonal. We actually can just count. So these are just kind of thinking problems and doing it, knowing that you don't need to use the formula. Now you go to number 8. That's a very, very small one, but you still got to make the triangle, even though it's still going to be a small one. So you are going to do evens only on this one. So let's write that at the top, evens only. And then I'm going to show you one from the back where you're going to use your graph paper. So looking out here, you're doing evens only. So I'm going to show you one of them. We're going to do 14 together. So again, just evens. So you'll use your graph paper. You're going to put these 2 points on one of the little graphs. So we're going to do here, we're going to do -7, 1. So we have to go over a little bit. -7's a little bit off the graph, but then we go up to 1, so it's about right here. It's okay if it goes off a little bit. And then -8. So again, we'd be at -8, that right here, and then we go to 2. So if you look at it here, this one's actually kind of hard to do, so that's why I'm doing it with you. If I put the other lines in, it might make it a little easier, but the other ones should be very doable because they should stay on the graph. But if I look at this, here's my diagonal. If I make a triangle, so again, I go down 1 and over 1. Those are my side lengths. So I do 1 squared plus 1 squared equals c squared. So it's that easy. So it's actually 1 plus 1. So that's when you do 1 squared plus 1 squared, you should actually just get 2 because that's 1 plus 1 equals c squared. And then our last step is to take the square root and undo it. So the square root of 2, second square root key 2 is about, C is about 1.4. So that's how we're going to do the ones on the graph. You only have 3 more. You're going to plot them. And the evens should be, you should be able to plot these on the graph, no problem, on the other 3 sheets of graph paper. Now we're going to look at practice 3 and do a few together. So pause.